Now, logarithms, there are two types of logarithms that we need to worry about. It's the one that you can find on your calculator, that it's this button here that says log, and the other one is next to it, and that button says ln. Now the difference between these is that they have different bases. So the base for the logarithm is the number 10. And the base for the ln, which is also called the natural logarithm, is the number e, which can be approximated to 2.72. But it's an irrational number, so it has an infinite number of decimals. Now, so far we've only explained the logarithmic function as an inverse of the exponential function. But we can try to find a different way of thinking of the logarithm as well. Now, I have this rule that I find helpful. The logarithm of a number is the exponent to 10 that gives you the number itself. Now, if you can memorize that phrase, that will be helpful to you in the future. So, just try to memorize the phrase, and eventually maybe you can make sense of it. But the important thing is to be able to remember this rule. Let's look at one example. So if you have an equation like this, 10 to the power of x equals 12. Now, this is an equation, so it means that whatever you have on this side must be equal to whatever you have on this side. And that would also mean that if I wrote the logarithm to 10 to the power of x, well, that would have to be the same as the logarithm to 12. So, consider what you have on this side here. Yeah, you have the logarithm of 10 to the power of x. Now, this rule here says the logarithm of a number is the exponent to 10 that gives you the number. So here you have an exponent to 10, and the logarithm of 10 to the power of x is the exponent to 10 that gives you 10 to the power of x. So we can generalize this to say that, okay, the logarithm to 10 to the power of x must be x itself, because that is the number that makes 10 to the power of x become 10 to the power of x. So it takes a while to find your way around this. But in our example, that simply means that we can write x rather than the logarithm to 10 to the power of x, and x is equal to the logarithm of 12. Now, when you punch this into your calculator, it's important that you use the right button. So you have to use the button up here, which is the 10 logarithm, rather than the natural logarithm. But we'll look at another example with the natural logarithm. Now, here we have a different example. ln x equals 3. So the natural logarithm to x is 3. And again, the purpose is to find x. Now, we have a very similar rule for the natural logarithm. So if I write natural here, so the natural logarithm of a number is the exponent to e that gives you the number. Yeah, so that's the rule we're going to use for the natural logarithm. Which means, well, we have to find the number that satisfies this equation, and the only number that fits would be e to the power of 3, because ln to e to the power of 3 is 3, because 3 would be the number which is the exponent to e that gives you the number e to the power of 3.